Okay, let's look at chapter 2.3, Venn diagrams and set operations. There's some construction going outside my office, so I hope that's not too disturbing for us. If it's too bad, I guess we'll pause and regroup. Okay, a universal set is a set that contains all the elements being considered in a given discussion or problem. For example, I mentioned in a previous video that you guys could be considered a set. The set of students in Prevet's online Math 1332 class. So a universal set, considering that set, might be the set of all the students at Weatherford College. It could even be the set of all college students in Texas or all college students in the United States. So it's important to know your universal set. And we can obtain a more thorough understanding of sets and their relationship to a universal set by considering diagrams that allow visual analysis. These diagrams are called Venn diagrams. And the universal set is represented by a region inside a rectangle. And subsets within the universal set are depicted by circles, sometimes ovals or other shapes, but usually circles. There are a number of ways to represent two subsets of a universal set. So let's look at those. Disjoint sets are sets that have no elements in common. So if I'm drawing a Venn diagram, the first thing I do is draw my rectangle, which represents the universal set. And then my circles inside here represent my two sets, set A and set B. If I draw them like this, then this represents disjoint sets. They have no elements in common. No matter how many elements are in here or here, there's not any elements that are in A and B. Proper subsets can be displayed in a Venn diagram like this. Because remember what it means to be a proper subset. Every element in A is also in B. So here's a representation of my two sets, but notice that every element that's in A is also encompassed in B. Equal sets would be drawn by two obviously equal circles. So if this is set A, and set B, they're equal. Now, this one is going to be our important one, overlapping or intersecting sets, where my two circles are going to overlap. Okay, set A and set B. In other words, it's possible to have some elements that are in A and also in B. Okay, now the reason this one is so important is because really this is the only one we need. We can depict all four of these circumstances with this one diagram. Think about if we were trying to depict disjoint sets. Then if my sets had nothing in common, this overlapping space would just be empty. So this depicts disjoint sets. Also, if I wanted to depict proper subsets, meaning every element in A is also in B, well then I could just make sure all my elements in A are in this region. And now I have a proper subset depiction. Okay, equal sets would mean all the elements in A and B are in the same section. They're equal, right? And then of course, intersecting sets, I might have some elements in A and some in B, some that's in A and B. Anything out here represents the universal set. Okay, let's make sure that we understand what these regions represent. Okay, so I'm going to go in and label them, each region, and you might see the regions labeled like this in some of your homework problems. So let's call this region 1 region 2, region 3, and region 4. Okay, the elements that belong to set A but not set B are in this region. The elements that belong to both sets A and B are in this region. The elements that belong to set B but not to set A are in this region. And the elements that belong to the universal set but are not in set A nor in set B belong in this region. Okay, so more Venn diagrams. Okay, the complement of set A is the set of all elements in the universal set that are not in A. For example, if I wanted to represent that with a Venn diagram, since we're just talking about one set here, okay, this shaded region out here would be the complement of A, right? The elements that are in the universal set but not in A. The intersection of sets A and B is the set of elements common to both sets A and set B. Sorry about that noise. And we've already looked at that, how we would choose the intersection of sets A and B. Let's look at it one more time. My Venn diagram. Okay, here's set A and set B, and this region right here is the intersection of sets A and B. The union of sets A and B is the set of elements that are in set A or set B. Notice intersection, recall, means the elements that are in set A and set B. So these are the elements that are in A and B. If I want the elements that are in A or B, it can either be an A or B or both. So the union of sets A and B is this region. Very important to distinguish the difference between the intersection and the union of sets A and B. All right, some problems involve more than one set operation. So the set notation specifies the order in which we perform these operations. Always begin by performing any operations inside parentheses. For example, if I was going to try to determine with a Venn diagram what it means to be the complement of A or B, first of all, I need to know what A or B is inside my parentheses. And we know that here's A or B, right here. Here's the set A or B. And so the complement means I want the stuff that is not in A or B. So my final answer here, I'm going to shade in red. This red shaded section is how a Venn diagram would represent the complement of A or B. All right. On the other hand, if I'm doing not A or not B, all right, then let me draw my basic Venn diagram again. All right, so I'm going to do not A. So not A is all of this stuff that's not in the circle representing A. Sorry, I went by that tail there. Okay, not A. Here's not A. All right, then I'm going to do not B in red. So not B is all of the elements that are not in B, in this case, in my circle B. And then I need to judge, what does it mean to be or? Well, or means it can either be this stuff or that stuff or both. So for my final answer, which will be shaded in black, right, anything that has a red or blue line is included in this set. So that would be everything but this part here. So I'd go back for my final answer and shade everything but that middle region. This is what it looks like to represent the set of not A or not B. Right? Anything except this football region. Okay. So let's recall that the cardinal number of a set is the number of elements in the set. We now want to consider the cardinal number of the union of two finite sets. A common mistake is to add the elements of the two sets. Be careful though. If the sets are overlapping, you may be counting some elements twice. For example, let me get a pen. Whoops, sorry. Okay, so for example, whoops, let me talk. So for example, let's say that A is the set 1, 2, 3, and B is the set 3, 5. And I want to know how many elements are in A or B. Well, recall when we're listing the elements, we don't list them twice, right, in a set. So really 1, 2, 3, and 5 are the elements in A or B. The cardinal number is 4, not 1, 2, 3, 4, 5, because I counted this 3 here twice. So here's a formula for the cardinal number of the union, if it's the union is the or, right, for the union of two finite sets. And this is going to be an important formula. We're going to use this in some other applications later in the course. This will come back up. It's the number of elements in set A, which in our case above is 3, plus the number of elements in set B, and then minus the number of elements in their intersection, the number of elements that are in A and also in B. So there's one element that's in A and B, so I need to subtract that one element. So 3 plus 2 is 5, minus 1 is 4, which is what we knew it to be. So I want to remember this formula right here, not only for this section, but we're going to refer back to this in the future also. So now let's go and look at some problems, see if we can work through some. Okay, so we're going to find each of the following, given that the universal set are the integers from 1 through 8, or natural numbers if you prefer. Set A are the elements 1, 3, 5, 7. B is the set with elements 1, 2, 3. C, 2, 3, 4, 5, 6. D, 2, 4, 6, 8. So if I want not A means I'm going to find the elements in the universal set that are not in A. Since 1, 3, 5, and 7 are in A, the ones over here in the universal set that are not in A are 2, 4, 6, and 8. So not A is 2, 4, 6, and 8. A and B. Now, people mistakenly think of this as, oh, A and B, and they list all the elements in A and all the elements in B. But remember, that's not what and means. And means it's the elements that are in A, and they are also in B. The elements that are in both A and B, and notice 2 is not in A and B. It's only in B. So the elements that are in A and B are 1 and 3. 5 is not in A and B. 5 is only in A. 1 is in A and it's in B. 3 is in A and it's in B. 2 is not in A and B, only B. 5 and 7, not in A and B. Okay, not A and not B. In order to figure out what not A and not B is, I need to know what elements are in not A and not B. Well, I've already calculated the complement of A up here, so let's figure out what elements are in the complement of B. That would be the elements that are in the universal set, but not in B. Okay, so B has the elements 1, 2, 3, meaning not B is 4 through 8. So 4, 5, 6, 7, 8. Now, again, and I'm interested in the elements that are in this set and also in this set. I see that there's a 4 that's in both sets, a 6 and an 8. So those are the elements in not A and not B. 2 is not in this set and that set. C or D. Now or, remember or means, oh, that's the elements in C or D or both. This is all of them. They can be in C or D, I don't care, all, or both. So my elements in C, 2, 3, 4, 5, 6, and D, 2, 4, 6, 8. So how about 2, 3, 4, 5, 6, 8? That are in C or D, not 7, 8. A and the empty set. And means the elements have to be in set A, and they also have to be in the empty set. Well, since there aren't any elements in the empty set, there aren't any elements in A and the empty set. No elements can be in both the empty set and A. Okay, either one of these notations is fine. Now, on the other hand, A or the empty set means, hey, that can be the elements in A or the elements in the empty set or both, right? Can be any or all of those. So 1, 3, 5, 7, or a shorthand way to write that is, hey, that's set A. Okay, the complement of A or D. Well, first of all, I got to work inside the parentheses. I got to know what the set A or D is. So if I'm finding A or D, it can be an A or D or both. So 1, 3, 5, 7, 2, 4, 6, 8. It looks like these are 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. So if I want the complement of that, that means I want the elements that are in the universal set but not in A or D. Well, all of the elements in the universal set are in A or D, so this would be the empty set. There are no elements in the universal set that are not listed right here in A or D. Okay, B and the universal set means it has to be the elements that's in B and also in the universal set. Well, 1, 2, and 3 are in both sets. So that's my answer. Which a shorthand way to write that is, oh, well, that's just set B. Okay, down here I got to do in parentheses first, so I need to know what A and C is before I can answer this question. A and C are the elements in A and C. So there's a 3 and a 5 that's in A and C. Now, I also need to know what's in not D. So what's in a universal set that's not in D? So that looks like 1, 3, 5, 7. Okay, now, or these elements, or those, or both. So in other words, all of them. 1, excuse me, 3, 5, 7. Not A and C. First of all, I need to know what not A is. Well, I've got not A already calculated up here. So and C, the elements that are in this set and also in this set. So 2 is in both sets, 4 is in both sets, 6. Not A and C. 2, 4, 6. Okay. Let's see what else we have. Now we have a Venn diagram. And it says use this Venn diagram to represent each set in roster form or determine the cardinality. Now these first ones are asking about the cardinality. So this is saying I want the number of elements that are in A or B. Remember, this represents A or B. It can be an A or B. Sorry, this should probably be. Let's list this as A and B so we'll know, because you know, I could put a B over here or an A. They really have to be labeled. Okay, or both. So the number of elements in A or B are 1, 2, 3, 4, 5, 6, 7. The cardinality of A or B is 7. The number of elements that in not A. Here's A. So what's not in A are 1, 2, 3, 4, 5 elements. The number of elements in A and B. This football region again are the elements that are in A and B. And so there are 2 of those. Notice how quickly we're able to determine these answers when our information is organized in a Venn diagram. Okay, now it's not asking about the cardinality, it's just saying find set A and B. Okay, well, that's the elements in this region right here. They're in the circle A, and they're also in the circle B. So that would be the set with elements 4 and 7. A or B would be the elements in this entire region. A or B. So, and we don't have to put them in order, but I'm going to, if I can, right quick. 1, 2, 3, 4, 5, 6, 7. Not A are the elements that's not in this circle. So 2, 5, 6, 8, 9. Not A and B. Okay, we already know which ones are not A. That's these. Here's not A. So if they also have to be in B, not A and B, then 2, 5, and 6. Right? They're not in A, but they are in B. Okay, the complement of A or B. So I know all of these are in A or B. So what's not in this region? 8 and 9. Not A or not B. Okay, not A. Here's the circle of A. So these elements are not A. Now I'm going to do not B in red. Here's my circle of B. So these elements are not in B. Okay, now remember what it means to be or. It means it can be either this stuff or both. So everything that's circled up there would go in this set. 1, 2, 3, 5, 6, 8, 9. All right, let's try one more. Set A contains 12 numbers and 18 letters. Set B contains 14 numbers and 10 letters. One number and 6 letters are common to both sets A and B. So find the number of elements in set A or set B. Okay, set A or set B. Remember, we have a little formula for that. It's the number of elements in A plus the number of elements in B minus the number of elements that are in A and B. Okay, so I know that the number of elements in A is 12 numbers and 18 letters, right? Or how about 30? And I know, oh my word, that the number of elements in B contain 14 numbers and 10 letters, so 24. I know that the number of elements in A and B, because it tells me that there's one number and 6 letters common to both sets, right? So that's 7. So I should be able to find the number of elements in A or B by doing 30 plus 24 minus 7. 30 plus 24 minus 7, or 54 minus 7, so 47. So there are 47 elements in set A or set B. Okay, I think that wraps us up for this chapter 2.3. Go in, try your homework. Let me know if you have any questions.